with number value. There is a value represent the compressive strength of concrete, and there is a value that can reflect how workable is the concrete through the SLAM test or any other workability measurements methods. So the workability can be reflected by number, SLAM value. Compressive strength of concrete can be reflected by the number, how much is the compressive strength with a 20 megapascal, 30 megapascal, 40 megapascal, or whatever number of compressive strength. The splitting tensile, the water absorption, and etc. All these uh, tests and properties, whether hardened or fresh or hardened properties, are reflected with number. But here, durability, it cannot be reflected with number. There is nothing that we can call what is the durability of concrete. So there is no number reflects the durability of concrete, because it is about behavior than properties, like about surface life. For how long the concrete can stay on its original shape and its original quality without maintenance. So, but there is some properties that reflect, gives you an idea about the durability of concrete, like the water absorption, rapid chloride permeability tests, and we have other of tests that can gives you an idea how durable is this concrete. So if there is any problem happen to the concrete, then the concrete start to deteriorate. So what is deterioration? Deterioration is the defect that has occurred over a period of time on the concrete. And there is many reasons that makes the concrete deteriorate and results, and in the structure would end up with failure. So if there is no problem, if there is nothing uh, will happen to the concrete, or there is no aggressive, if the concrete is not exposed to aggressive environment, then the concrete is supposed to stay on its original shape. Nothing will happen to the concrete over time. But if there is any defects or any reasons that makes the concrete deteriorates, then the concrete will start changing. Then the original shape and the quality of the concrete will start to change, and deterioration will happen to the concrete and would end up with the structure failure. And the most common deterioration happen to the concrete is the corrosion of the steel bars. And there's many reasons that makes the steel bars corrode in the concrete structures. And we will come and we will see some uh, causes and factors that result, that makes the concrete structure failure as a result of the corrosion of the steel bars. So concrete may deteriorate through over time, and the most common durability failure is the corrosion of the reinforcing bars. There is also other factors. If the concrete is exposed to the aggressive environments, chemical attacks, if the concrete is exposed to the water and the water here is containing sulfates, acids, and these chemical will start to attack the concrete components and will result in deterioration of the concrete and the concrete failure. So any concrete failure, the reasons of the concrete failure will be as a result of two factors, two major factors. It can be either external factors that affect the concrete structure, or factors, internal factors, that as a result of the ingredients, the concrete ingredient itself. If there is any defect or any problem with the concrete ingredient, the aggregates, the cements, the quality of the cement, the quality of the aggregate, if there is any problem with the concrete ingredients material inside, this also will, it there is a factor, and there is it could be a potential for concrete deterioration and concrete failure. External factors is example like if there is any attack and the concrete is surrounded with aggressive environments, and this also could be reasons and causes for the concrete failure. So what are the factors? Here are a list of factors that may results in the deterioration of the concretes, the environments, external environments, the cover of the embedded steels. Here is the concrete structures and the steel bars here, and there is a cover that the purpose of this cover is to protect the steel bars. And if there is no sufficient cover or the concrete quality here, this cover, there's a problem with the concrete quality, and then it will allow the water, it allow the chemical attack, and allow all this one to penetrate and reach to the steel bars. Then the steel, when the steel bar get in touch with moistures and water, then definitely corrosion will start to happen. The cement contents, the water cement ratio, this is also internal factors. The mixed design of the concrete, the shape and the size of the members, and permeability, abrasion, etc. So these are examples of what are the factors that may end up with the concrete failure as a result and of deterioration. Causes of deterioration also, this is an external factors, and some are internal here. Carbonation, sulfate attack, chloride attack, freeze and thaw, alkaline silica reaction, acid attack, and etc. So these are, some are external, some are internal, like carbonation, sulfate attacks, and chloride attack are external factors, in which the alkaline silica reaction is internal factors, because alkaline silica reaction happen when there is a high alkaline component in the cement. It will start react with the silica in the aggregates, then deterioration will start. So you need to know the factors also affecting the durability of concrete in terms of the cement contents, in terms of the aggregate quality, in terms of the compaction, the curing member, permeability, moisture. So there is so many factors. You don't need to know only the list of factors, but you need to know how each factor will affect the durability of the concrete. Compaction, like how the compaction will makes the concrete deteriorate or will contribute to the concrete failure. How poor compaction, I mean. So compaction is one of the, as example, is one of the factors that may affect the durability of concrete. How? Because poor compaction will result in a voids. Like, what is the purpose of compaction? Compaction, we vibrate the concrete in order to allow the concrete mix to fill up all the voids and fill all the spaces, remove the bubbles, and makes the concrete more dense. So if there is poor compaction, like the concrete has poor vibrated, then it will end up with voids. The concrete doesn't reach and fill all the spaces. Segregation may happen, and all this one will end up with the allowing the water and moistures. The existence of voids will allow the water to penetrate and reach to the steel bars, and will lead to the concrete deterioration. The aggregate quality, as I said, there is internal factors as a result of the concrete ingredient itself. If we have poor cement quality, the quality of the cement is poor, the quality of the aggregate is poor, the water to cement ratio is high, All these are factors that affect the durability of concrete. So you need to know how the aggregate quality will affect, how the curing period, how the water cement ratio. These are kind of a question that you will be expected in the exam. In terms of the aggregate quality, the most common how the aggregate affect the durability is the aggregate silica reaction or alkaline silica reaction. We will get to know in details about this one. So aggregate quality, the source of the aggregates, the chemical composition of the aggregates, and how clean is the aggregates. This one will affect the durability of concrete. The cement contents, how much cement we have in the concrete mix design. So in general, not only the cement contents, but the mix design, which the factors in the mix design, how much cement do we have, how much is the water to cement ratio. So the mix design also can be a factor or can be considered as a factor affecting the durability of concrete. And you need to know how the cement contents can contribute to the deterioration of concrete failure and how we can improve the quality of the concrete in terms of the cement contents. So the cement contents also the high amount of cement is okay. So the cement contents, it should be relatively high to increase the compressive strength of concrete. But at some point, there is an optimum of the cement contents. But at some point, if the excess of the cement in the concrete will start negatively affect the concrete. So initially, yes, there is the strength and durability. It can improve with the increase of the cement contents. But at some point, the excess of the cement, if there is too much cement or binder contents, it will start negatively affect the quality and the durability of the concrete. Why? Because the excess of cement or binder contents is one of the reasons, if you do remember, of the shrinkage, is one of the results in the shrinkage. There is a potential for shrinkage will happen if we have excess high amount of cement. And of course, shrinkage, it will end. What is shrinkage? Shrinkage is the volumetric change in the concrete. So the concrete is shrink over time, doesn't expand. The concrete is shrink. And as a result of the shrink, we start to see cracks on the surface of the concrete. And when we have cracks, then we will have voids, and then the water start to go through these cracks, penetrating the concrete, reach to the steel bars and corrosion, and it will end up with the structure failure or deterioration will start to and affect the durability of the concrete. So cement contents, water cement ratio, aggregate quality, all these one are can be either internal, this is processing factors when we do the concrete casting, curing also one of the processing. How curing, this is how question is coming, like what are the factors, explain how the cement contents, how curing will affect the durability of concrete. So you need to understand the words how curing, how the cement contents, how the quality of the aggregate affect the durability of the concrete. So we have so many factors. And in order to avoid or improve the durability of the concrete, that you need to make sure that the concrete can stay on its original shape with original quality for long time. So you need to increase the surface life of the concrete. So how to improve the durability of the concrete? How to improve the surface life of the concrete? By considering the factors that affect the durability of concrete. You need to list all the factors and study how each factor affect the durability, how each factor affect the quality of the concrete. And you need to know, since you know how and how this one results in poor quality, then you need to try to mitigate and avoid the effect of each factor. So for example, if I ask you how among different factors affect the durability of concrete is the aggregate quality, briefly discuss how the aggregate quality can contribute to the deterioration of the concrete, or can contribute to the concrete failure, and how to avoid the effect of the aggregates on the deterioration of the concrete. So you need to explain that aggregate is one of the internal factors that affect the durability of concretes. It's one of the main concrete ingredients, and it's almost occupies 75% of the total concrete volume. So if there is any small problem with the aggregates, and since it occupies 75%, like majority of the concrete is aggregate, 75% of the total concrete volume is aggregates. So if there is small problem with the aggregates, it will make a significant change to the whole concrete, because majority of the concrete are aggregates. So you need to make sure that we are using a high quality aggregate that should be well graded in order to make the concrete more dense. Aggregate should be free of any chemical. Why? Because aggregate silica reaction is one of the reactions that it will end up with the concrete failure. And the reason of this concrete failure as a result of the alkali silica reaction is because of the poor aggregates, because of the existence of the silica in the aggregate. So we need to make sure that we have a clean aggregate, strong enough, free from any chemical, in order to avoid the alkaline or aggregate silica reaction. So, and there is 3 methods to mitigate and avoid the alkaline silica reaction as a result of the poor aggregates, and we have 3 here mitigation, 3 methods to avoid or minimize the potential of alkaline silica reaction to happen in the concrete. We'll get to know this one when we reach. Abrasion, also one of the factor. Moisture, also permeability. How permeable is the concrete? So permeability is also one of the factors that affect the durability of the concrete. And how permeability can affect the durability, and how we can improve the permeability, improve the concrete permeability in order to avoid the deterioration of the concrete. So, but before, we need to understand what is permeability. Permeability, actually, it is how much and how easy the water can go and penetrate the concrete. And how to measure the permeability is by the most common test that we do in the lab to determine or get an idea about how permeable is the concrete is the water absorption. We We bring a sample of concretes, we put it in the oven for 24 hours, and then this sample will be totally dry from the surface and also from the body inside. So it will be totally dry. Then this uh, we weight this sample. We record the weight of the sample, totally dry sample. Then we submerge it in the water for also 24 hours. Then when we submerge it in the water, then the concrete start to absorb water and store the water inside the sample. So we come the next day, we take it out, we dry the surface, and we weight the sample again. So the weight definitely will be higher than its weight when it is totally dry, because there is additional weight coming as a result of the water absorption and stored inside the sample. Then we calculate the percentage of increase in the weight, and the increment in the weight will be as a result of the water, the water that already absorbed in the concrete. So how much is the concrete absorb water? The higher the water absorption, the higher the amount of water already absorbed inside the concrete will be the higher permeable concrete, will be the low quality concrete. And the low water absorption, if the concrete doesn't absorb so much water, like the amount of water that absorb is less or low, it reflects the low permeability of the concrete. It means that the concrete doesn't absorb so much water. It means that the concrete is more dense and it doesn't allow the water to go and penetrate the sample or penetrate the concrete. So the concrete tries to block and prevent the water to penetrate and reach to the steel bars or penetrate inside the concrete. So if you have a question, true false question, that the high water absorption is the high durable concrete, true or false? It's definitely false, because we are trying to minimize the water absorption inside the concrete. So permeability is how it's the resistance of the water to allow to the resistance of the concrete to allow the water to penetrate inside the concrete sample. So start reading here. Concrete durability get affected when there is a chance of permeability of water into the concrete. Permeability of water into concrete expand its volume and lead to formation of cracks, and finally will end up with the concrete failure. Sorry. To prevent permeability, lower possible of water cement ratio must be recommended. The use of mineral admixtures, filler admixtures. So these are the so the question will be how the permeability. There is so many types of question you can expect here, or for any factors. The high, as I said, the high water absorption of concrete is the higher durable concrete. No, this is wrong. The permeability, we try to reduce and prevent the permeability of the concrete. We are trying to prevent or we are trying to increase the resistance of the concrete against the water. So we are trying to design a concrete that can block the water and doesn't allow the water to penetrate inside the concrete. This is how. Now, the other question will be, so we understand that we need to decrease the permeability. We need to decrease the water absorption. So this is our target. Now, how we can achieve it? How we can decrease and prevent the permeability of the concrete? How we can reduce the water absorption of the concrete? So how to prevent the permeability of concrete? It's by the most common answer for this one. If you confuse with anything, if you don't know the answer of anything, how to improve the workability, how to improve the how to improve the quality of the concrete, how to improve the compressive strength, flexure strength, splitting tensile, or whatever property, how to improve the quality of concrete in general by reducing the water to cement ratio. So if you don't know the answer of any question, you just write reduce the water to cement ratio. So this is the key answer of any question that you may see in the exam or in any elsewhere. So the most sensitive parameter in the concrete is the water. In the mixed design, when you design the concrete, the most sensitive parameters or ingredient in the concrete is the water content. If there is small change in the water contents, it will make a significant change on the concrete properties, different than the aggregates, the aggregate or the sand, big stone. Like in the mixed design, for example, if you design a concrete with a specific number of kilogram per cubic meter of the cement, and you have another specific kilogram per cubic meter for the aggregates, and kilogram per cubic meter for the water, and you are supposed to use, for example, 200 kilogram per cubic meter for the water as example. If there is an error during the mix and you use 210 kilogram per cubic meter, there is 10 kilogram per cubic meter extra as an error you have done in the lab or in the mix. So this small change, the small addition of the water, it will make significant change in the properties of the concrete, on the compressive strength, durability, or whatever properties. In which if you have add this 10 in the, if you did this mistakes in the aggregate, in the sand, nothing will happen. It will not make any change in the concrete quality or concrete properties, the compressive strength. No, but small change in the water, it will make a significant change in the concrete properties, the compressive strength. Like if you add, you are supposed to use 200 and you use 210 of water, then there is a significant change in the compressive strength. But if you are supposed to use 500 of the sand or fine aggregate, 500 kilogram per cubic meter, but you accidentally, by mistake, you use 510 of the sand. So you will not absorb any change in the compressive strength. But if you use the water, if there is an error, accidentally use small dosage of the water or reduce, it can be either extra or reduce the number of the quantity of the aggregate, you start to see the change in the properties of the total concrete. This is the key answer of any question that you write. Just write reduce the water to cement ratio to generally improve the quality of the concrete by increasing the strength, reduce permeability, increase the durability of the concrete, etc. Like we always recommend to use the lowest water to cement ratio as possible. The other method in order to prevent the permeability of the concrete is by using mineral admixtures. What are the mineral admixtures? Or pozzolanic material. In other names, they have also another name. They can call it cementitious supplementary cementitious material or supplementary cementing material. So if you see these three names, they are the same material. Some people they call it pozzolanic material. Some people call it mineral admixtures. Some people they call it supplementary cementitious material. So they are the three names to the same material. What are these material? These are example of this material are fly ash, silica fume, methacholine, rice husk ash, etc. And this material is actually byproduct and waste material from different industry, different factors. And they use this material. It comes in a powder form, and they use it as a cement replacement or partially cement replacement. So they take out 5%, 10%, 15%, depends on what material are you using and how much percentage you need to replace the cement with this material. Then you can use it as a cement replacement. Okay, so the use of this material as a cement or partially cement replacement, it will improve the quality of the concrete. There's several ways this material or the use of this material can improve. I think we discussed this one before. The first one is by the pozzolanic reaction. It's these materials contains high amount of silica. This silica will react with the calcium hydroxide as a result of the hydration and convert it to the calcium silica hydrate. And as we said before, the high calcium silica hydrate is the higher strength of the concrete, because calcium silica hydrate is actually the source of the strength in the concrete. The other way that this material can improve the quality and the durability of the concrete by filling. It has a high filling ability, and it can fill in the voids inside the cement paste. So what makes the concrete, or what makes the water penetrate through the concrete? Because the existence of voids, it can go through voids. But if the concrete is more dense, there is low voids, then it will block the penetration. It will stop the penetration of the water inside the concrete. So what this material do, it will start to fill all these voids by packing, improve the packing density, and makes the concrete more compacted, more dense, so it will reduce the potential of any water to go and penetrate in the concrete. So how this happened? Because the particle size of the cement will be different than the particle size of this material. And if we take silica fume as example, silica fume, the particle size of the silica fume is 100 times smaller than the particle size of the cement. So these small particles start to fill in the voids between the cement particle size. So it will make the concrete more dense and compacted, and it will improve to and will contribute to prevent and avoid the permeability of the concrete. Moisture also here is one of the factors you need to read and see how these can contribute to the deterioration of the concrete abrasion as a physical, external physical factors that also can end up with the concrete deterioration. This is the internal factors, the the alkaline aggregate reaction or alkali silica reaction. So this reaction happen inside the concrete when the alkaline from the cement, the high alkaline cement, it will start react with the silica in the aggregate. That's why we already discussed this one. So when aggregate, the source of the aggregate, there is problem with the source of the aggregate, that the aggregate contains reactive silica. Then this reactive silica will start to react with the alkaline existing in the cement. So alkaline will react with the silica from the aggregates and we'll get the alkaline silica reaction. So what this reaction do and how this reaction can affect the quality and the durability of the concrete, these are as a result of this reaction. So it will end up with the cracks, maps, and you might find some gel coming to the surface of this concrete. So these are as a result of the alkaline silica reaction. So what actually happened? This is the particle of the aggregates and it's surrounded with the matrix or the cement base. The cement, we have alkaline components in the cement. This alkaline will start to react with the silica from the aggregate, alkaline silica reaction. So as a result of this reaction, we'll start to see some components as a result of this one. And the volume of the results is higher than the original volume. So the volume inside the concrete and specifically inside the aggregates will be getting much higher and higher. So there is a volume inside the concrete is growing. The volume, there is something volume here, is growing over time as a result of this reaction. Then it will start to push the surface, push the material, and it will end up, if you can see here, if there is a volume increasing, then we'll start to see cracks inside the concrete. And it will end up with these kind of shapes, and it's definitely a problem. The volumetric change, the existence of the crack, it will allow the moisture and the water, carbonation, acid, and any chemical that can easily go and makes the concrete deteriorate. So what is alkaline silica reaction? You need to know what is this reaction, who react with what who react with what is the source of each component, and the most important thing is how to avoid the occurrence of this reaction, how to avoid the alkaline silica reaction, because this reaction, it will end up with the concrete failure. So if you know what makes reaction happen, it happened because the high alkaline components in the cement will react with the high silica component from the aggregate, then it will and with the existing also with water, it will start reacting. So how to avoid? We need to limit the alkaline component. We have alkaline from the cement and we have silica from the aggregate. So how to avoid? We need to limit the alkaline metals or the alkaline component from the cement. And also we need to limit the silica from the aggregates. And also we need to, because this reacting start happen with the existing of water. So how to avoid the existing of water? By using mineral admixtures, slag, silica fume, all these ones, supplementary cementitious material, pozzolanic material. It will make the concrete more compact and will avoid the water and the moisture to reach to the concrete ingredient and reach to this one, and this one will start to happen. Sulfate attack is also one of the external factors that affect the durability of concrete. When the concrete is surrounded with aggressive environment that contains sulfate, then the sulfate will start to attack the concrete ingredients, and it will end up with the concrete deterioration and concrete failure. You need to know how sulfate attack the concrete and what is the source of these sulfates. There is two type of source of the sulfate that attack the concrete ingredient. So the sulfate can be either coming from the internal source or external source. Internal source, when you use, for example, the water that you already used during the concrete mix contains some salt, or Portland cement might be over sulfated. The material or the cement that you are already used is over sulfated, or the water or whatever. Example of external source that it will not be part of the concrete ingredients. It means that the source will be outside the concrete. It can be either from the soil, the groundwater, or industrial waste water. This one, any source of sulfate can be existing as in the soil or the underground or groundwater when the concrete is always exposed to this aggressive environment. The concrete is exposed to the groundwater that contains high amount of sulfates, then this source of sulfates will start to attack the concrete components. So how to protect the concrete from any sulfate attack? Before this one, before you look at this one, the first thing is reduce water to cement ratio. So reduce water to cement ratio is the key answer of any problem, the solving of any problem. How to generally protect the concrete, how to generally improve the quality of the concrete. Always write reduce water to cement ratio, because this is the main reasons. Like, for example, ensuring sufficient degree of impermeability, use low water to cement ratio, reduce permeability and porosity. I need to reduce permeability of the concrete. I need to reduce the porosity, like reduce the voids. One of the methods to reduce the void is reducing water to cement ratio. The other method is to use pozzolanic. We already discussed this one. Filler material, mineral admixture. This one will contribute when it's consumed the calcium hydroxide and converted to calcium silica hydrate, and also can contribute by the filling ability or filling capability to fill all the spaces inside the cement matrix or cement paste. And this is how the sulfate attack resulted in the concrete deterioration and the failure of the structure. The other deterioration of concrete is as a result of corrosion. If we define what is corrosion, ASTM actually defined the corrosion as it is the chemical or electrochemical reaction happen between materials, and usually metals material, and its environment that produce a deterioration of the metals of the material and its properties. So corrosion of steel reinforcing is a major problem that influencing the long-term performance of the concrete structure. And this is actually the most common failure of the concrete, or as a reason of the concrete failure. So reinforced concrete, when it get touched with the water, corrosion will start, and we'll start to see that the volume or of the concrete start to reduce as a result of this reaction, of the chemical reaction that will end up with the structure failure. So reinforced concrete will begin to slowly corrode when exposed to a natural environment. So for steel embedded in the concrete, corrosion results in the formation of rust, which has 2 to 4 times the volume of the original steel. Then, as a result of this one, there is a rust, and the outcome, the volume of the outcome of this reaction is actually higher than the original volume of the original volume of the material that they are reacting together. So there is volume inside, start to increase, then it will try to push. There's volume is expanding. There is something inside the concrete is the volume of something inside the concrete is expanding and increasing. So this one will try to push the material to the surface, and it will end up with something like this, spalling. We call it spalling, and all will contribute to the concrete failure. So what is the reasons of starting corrosion in the concrete? There are many reasons. The most common two reasons here is by bicarbonation and chlorination. These are one of the reasons that makes the concrete corrode, make the steel corrode. And what are the factors that makes also the corrosion happen? We have permeability. Now it's become clear that permeability, the high permeable concrete, is the high potential of the water to go and penetrate to the concrete, reach to the steel bars, corrosion will start. Alkali aggregate reaction, when there's alkali aggregate reaction, then it will end up with the cracks. It will end up with the cracks, voids. This one will allow the water to penetrate, helps the water to penetrate and reach the steel bars. Corrosion will start as a result of this reaction. The moisture also component of the concrete resistivity, how much is the concrete can resist or blocking the water to penetrate. So what also, there is another factors, carbonation is also one of the reasons or factors that makes the concrete deteriorate or make as a result of the corrosion. So carbonation is the result of the dissolution of CO2 in the concrete pores fluid, and this react with the calcium. So this carbonation will start to react with the concrete ingredients. So in the presence of chlorides and other causing agents, the steel protection passive layer is locally destroyed. There is one thing here: when the concrete when we have concrete structure, and the concrete is a composite material, actually, or the concrete structure is a composite material of concrete and steel bars. And as we said, discussed before, that there is bond in the only concrete. We are using aggregate, so there is a bond between the aggregate and the cement paste, and this bond is essential to protect the concrete, or essential to reflect the quality of the concrete. So how is the bond between the aggregate and the cement paste is important. It's one of the three main factors that reflect the quality of the concrete. And if we use steel bars here also, there is also bond between the steel bars and the concrete. There is a bond between the steel bars and the concrete. How the steel bars are connected and bonded together. So this one is, we call it protective layer. So how the concrete are bonded with the steel bars, it's bonded with a layer, we call it protective layer. This is protective layer. So this protective layer, it actually protect the steel bars, protect it to be to get in touch with any water or moisture or any uh, material or any components. So it's like cover layer that protect the steel bars to be to avoid it to get in touch with any factors or anything that can affect the steel bars itself. So reinforcing steel in the core is normally protected from the corrosion by the passive film. This is a passive film or protected layer formed at the steel concrete border, the border and the bond between them. This passive film stops iron dissolution and is stable at pH is higher than 10. We all know the pH value. So if the concrete, if this layer is the environment of this one is has a pH higher than 10, then this layer, the steel bars, will be protective for a long time. It can, like the quality of this layer of this film has is good when pH is higher. The higher pH is the more stable, the more protective steel bars. Okay, so how carbonation here will affect the corrosion? When carbonation of the chlorides CO2 start to penetrate and reach to the steel bars, then it start to affect the pH value or the pH value surrounding on the steel bars. So it will start to reduce the pH, reduce the pH value, the environment here, the pH value, reduce it. And as I said before, that the passive film, it has a good is stable at high when it's surrounded with high pH value. But when the pH value is low, then we'll start to see that there is problem happen to the protective film or the passive film. So the passive film will start to destroy or being affected when the carbonation reach to this one. So when the carbonation reach, it will convert the environment and it will reduce the pH value. The carbonation will reduce the pH value and thus it will destroy and affect the protective layer. And this protective layer, sorry, it will the purpose of this one is to protect the steel from corrosion. And if this layer, passive film, the protective layer is already destroyed as a result of their low pH value, then it will be much easier, high potential for the steel bars to corrode. And corrosion will start to happen as a result of the carbonation and the existing of the CO2. So fresh concrete is highly alkaline. So highly alkaline. So high alkaline, it means that it has high pH value. Because of the hydration products such as calcium hydroxide, this environment protects the steel reinforcing part from corrosion. So the environment of the high alkaline environment is the good environment to for the steel to be protected. But if the environment, if the alkaline reduce the value which reflected by the value of the pH, when the pH value is reduced lower than 12, lower than 10, it can reach down to 7, 5. So the lower is the low quality of the passive film, and the steel bars will be no longer protected from the corrosion. So corrosion will start. So this is actually the end of the durability topic. We define the durability, and you need to know the durability factors that affect the durability of concretes. And we have so many factors, starting with the processing factors, external factors, internal factors, permeability properties. All this one is it's actually so many things that affect the quality of the concrete. You need to cover all these factors. It's not only listing. The question would not be like just what are the factors, that's all. List the factors that affect the durability of concrete. No, it will be what is the fact. Okay, for example, like the quality of the aggregate, for example, the quality of the aggregate is affecting the durability of concrete. Briefly discuss how the aggregates affect the durability of concrete and how to improve and how to avoid the deterioration as a result of the aggregate, as example, or the uh, corrosion, sulfate attack, water cement ratio. And you need to know how to protect and how to improve the durability of the concrete. How to improve the durability of concrete. The first answer without thinking is reducing water to cement ratio. If you don't know the answer of any question, you just write reduce water to cement ratio. Okay, so we'll stop here for today.